Welcome back to another video. This is Hello 2024 of Codeforces. We're gonna solve the third problem, that is grouping increases. So grouping only increases here, but our rating does not increase, but no problem. Let's keep practicing. So we have an array A of size n. So let's take a sample array like 1, 2, 3, 4, 5, and you'll do the following process to calculate your penalty. Split the array A into two subsequences S and T. Subsequence means what? You can select those numbers in the same order by removing certain elements. So 135 I'm taking, and balance is 24. You should put in T. So whatever number you take, it should be either part of S or either part of T subsequence. After this is done, they are telling for an array of size M, define the penalty as an array B as the number of indices I between 1 and m minus 1. That is, when bi is less than bi plus 1, we can say that there is a penalty of 1 that is added. So in this case, the left number is less than the right number, right? So penalty 1 gets added. 3 is less than 5, again penalty 1 gets added. 2 is less than 4, again penalty 1 gets added. So the total penalty for this combination of subsequence is 3. There may exist a subsequence below this or above this. They're asking what is the minimum possible penalty you can receive. So you have to find S and T such that the minimum possible subsequence is possible. So we have to report only the minimum possible subsequences penalty. We don't have to tell what is the subsequence. Now to make it clear, let's take this 5, 4, 3, 30. So 5 is greater than 4 is greater than 3. So the penalty is 0 here. 0 here. Only for this the penalty is 1. So total penalty is 1 here. So let's understand this with the help of an example so that it will be more clear. So 1, 2, 3, 4, 5 is here. So for 1, 2, 3, 4, 5, they took 2, 4, 5 in one array, 1, 3 in different array. 2, 4, 5, the penalty is 2 less than 4 less than 5. Penalty is 2, penalty is 1, total is 3. For 8, 3, 1 they took here, and 2, 1, 1, 7, 2, 1, 7, 4, 3 they took here. For 8, 3, 1, it is a decreasing sequence, right? So the penalty is what? It is 0, because there is no number where the left number is less than right number. The consecutive numbers are not there. Here only 1, 7 is here. That's why the penalty is 1. 1 is less than 7. Others are all decreasing. So 1. Now, by seeing this, what did we observe? We will think that, okay, we'll put all the decreasing numbers in one array and increasing numbers in other array. So decreasing numbers, how do we optimally choose it? We'll think that, okay, let's take the longest decreasing sequence that is possible, and the balanced numbers that are left out, we can put it to other array and calculate. But how did we derive this longest decreasing sequences? There is already an algorithm for longest increasing sequence where you recurse and memorize or do tabulation approach. It's like a DP problem. The standard way is it's like a n square algorithm. But the problem is the n value here is 2 into 10 power 5. So definitely the n square value won't work at all. N square can maximum work till 10 cube or at max at 10 power 4 also. But here it won't work. So we have to optimize that complexity further so that longest decreasing subsequence is not going to work. That algorithm not going to work. So that may or may not work, but we'll get TLE for sure. What is one thing we can do is we have to classify these numbers into two, right? If you have an array A, you have to put S and you have to put it into T. We'll try to do in something like a greedy approach. Whenever we are choosing a number, we'll decide whether we have to put in S or whether we have to put in T. So let's put that this is S and this is T. There are some numbers that are already inserted, T also already inserted. We have a number A. For simplicity, let's assume that the last number of S is SL, the last number of T is TL. And in order to make our algorithm standardized, I can say that SL is less than TL. Okay, so this is our assumption. See, it may happen that SL is greater than TL, but our only goal is one of them should be less. So if SL is greater than TL, I'm automatically assuming that T comes first and S comes second. If this is there, I am putting it here. So how do we solve in the coding way is, I can just swap these numbers, right? SL and TL, I'll just tell you. So for now, SL is the S last value and TL is the T last value. And we assumed that always this number will be less than this. Now, let's take an element X. So there are many elements like X, Y, Z here. Let's take X. What are all the possibilities X can have? X can be inserted here. X can be inserted here, X can be inserted here. That means what? The value of X is less than SL. So if the value of X is less than SL means it automatically means that it is less than TL also, right? So suppose if SL value is 5, TL value is 10, X value is 2, where will I put so that our answer will be optimal? We are just going with gut and intuition feeling only. If I keep here, the penalty is what? 0. Instead of this, if I keep here, the penalty is what? It is still 0 because it's a decreasing sequence, right? 10 is greater than 2, it's a 0. So what is the optimal way I can put? The best way I'll put is the sequence that is having the least number, because tomorrow, I don't know, some number like 9 comes, I can insert it here, right? If I put 2 here and erase 2, 9 can't be inserted here. If I insert 9 here, I have to pay for one penalty. I don't want to pay penalty. I want to minimize the penalty. So that's why in this case, I'll put 2 here. So with the minimum number. So if this is the case, if X is less than or equal to this, then I tell that the last value I am inserting here to 2. That is, I just want to keep track of the last values only, because every number will be consecutive. So bi and bi plus 1 only we are calculating. So last value only we are taking. Now we understood this case. Let's go for the another case where X value is between SL and between TL. Now, how will that case look like? Here 10 here and 100 here and 50 here. If I place 50 here, the penalty will be 1. If I place 50 here, what is the penalty? 0. So obviously, if it is between both of them, 10 is less than 100, I can say that this can be placed here. That is, if the value is greater than or equal to TL or less than or equal to TL here. It is less than or equal to TL. What can I say? If it is greater than or equal to SL and less than or equal to TL, obviously I can say that TL can be placed with X. So this is not 2 here, this is X. Again, X is less than or equal to X means this here. So penalty will be 0 if I place it. Here also it will be placed. We are optimally placing here. And similarly, if it is in middle, I assume that it is less, right? So if it is less than this, I can place it here. So it will be 0. What is the next possibility? The value of X will be somewhere here. In this case, what happens? So I have a 10 here, I have a 100 here, and here I have 1000. Okay, so let's remove some zeros. Okay, we have 1 here, 10 here and 100 here. Where will I place 100? I can place 100 here, I'll get a penalty of 1. If I place 100 here, I'll get a penalty of 1. Where will I place? I can place both, penalty is 1. But we have to think about our future also. So if I place here, tomorrow, for some reason, if someone comes here, I cannot place any number. But if I place 100 here, I can place numbers from 1 to 99 with 0 penalty and 1 to 9 with 0 penalty. So what is the optimal way I can choose? I will choose it to place here because I am increasing the chances for this subsequence to get to 0 penalty. That's all. So what did I say again? If I don't place 100 here, if I place 100 here, the chances of getting a 0 penalty is impossible, right? There is no number you can get 0 penalty. Here 1 to 99 you can take. But if you place 100 here, you have the chances of getting a 0 penalty. If any number on this range comes as the next number, the chances increases here. And here also the chances are there, 1 to 9. So both ways the chances are there. So I am putting this 100 to the smallest number, smallest subsequence. So if this is the case, this is a else if case. Else if case means it is between both of them. And in else case, what else case is, we are incrementing the penalty. In both ways I am incrementing the penalty and I am putting the smallest number. So the smallest number is X. Now again I'll go through the loop and find the next element. Before finding the next element, I need to make sure SL is less than TL. So if SL is greater than TL, what do I do? Generally means that these are just arrays, right? I just don't want to know the position. I assume that the T value is above and S value is below. or else you have tried for two condition. If TL is less than SL or SL is less than TL, that doesn't matter. So that's all. We derived it. Let's see the code now. So what did we do? If SL is greater than TL, I have to swap it because we are assuming that SL is always less than TL. Value is less than or equal to SL means S last, T last. If it is X is here, if the value is somewhere here means uh, it will be 0 here, it will be 0 here. Optimally we understood that val keeping here will be the best thing. Now val less than or equal to TL means what? Val is greater than SL and less than TL. So the optimal value is here only. So with 0 penalty. In the other case, as I explained earlier, there is a room for more decreased penalty if we place the maximum value in the S position, if S is lesser. So that's why we are incrementing the penalty, and SL equal to val, we are putting the penalty here. There is editorial that is published with greedy and DP solution. So what I explained is basically based on greedy only. So mathematical proof is something which I can't do. So this we are going just with the hunch. So what did we understand from here? We saw this example, we understood the question, we understood that longest decreasing sequence can't work here because of the time complexity. So I thought of doing something like a greedy approach. What is a greedy approach? Whenever I see a number, I am classifying whether it should be part of S or it should be part of T. So so if it is, so I need a standard way to do it. So I always assume that S is less than T. If S is greater than T, I'm just swapping the last elements. Swapping the last elements doesn't mean that I'm swapping these two. I'm swapping the entire array. I'm just keeping track of the last elements. So that is one important thing you need to find. It is not the last two numbers only. I am swapping the entire array. So that is something you keep in mind. Now I take all the possibilities. What if the number can come here, the number can come here, the number can come here, which can give me more room with the decreased penalty, I would see. So and in future also I'll think who can be a better candidate for a penalty that will be much lesser. I'll always aim for penalty 0. Wherever it is possible, I'll just do it. So that's it guys, and this is the accepted solution. So if you have any doubts, please let me know in the comments, and please do check the editorial also. Thank you guys, thank you so much. If you like the video, please share the comments and don't forget to subscribe so that it motivates me to do even more. And please like the video also. Thank you.